Here are 10 unique ways to find pi. Archimedes pentagon. Take a circle of radius 5 and inscribe a pentagon in it. We can find the pentagon's perimeter to be 29.4. Since the circumference is greater than the pentagon's perimeter, pi must be more than 2.94. We then repeat for polygons with more sides to gain a more accurate result. Monte Carlo approximation. Take a square with a radius 2 circle in it. The area of the square equals 4, and the circle equals pi. The ratio is 4 to pi. Now place random dots in the shape, as many as you can to increase accuracy. The ratio of dots inside to the total number will be 4 to pi. Leibniz formula, this is complex, so let's break it down. This means we multiply every term by 4, and this generates a series of odd numbers in the denominator going 1, 3, 5, 7. This alternates between positive and negative numerators because -1 to a positive number is positive, and vice versa for negatives. This is what it looks like together. Buffon's needle. Imagine infinite equally spaced lines, with the distance between them being d. The length of needle we have is L and is less than d, which is dropped randomly. We drop it n times, and the probability of it crossing a line is the number of crossings over n. Now, using a separate formula for p, which is obtained elsewhere, we get another equation, which simplifies to find pi. For example, L is 2, D is 3, N is 1,000, and total crossings is 320. We would get pi equals 3.125. Euler's identity, which is a bit of a stretch. We start with the identity, rearranging to equal -1, where we can take the natural logarithm of both sides. Given that the natural logarithm of e to the x equals x, we get I pi equals natural logarithm of -1. So we can conclude that pi equals I times the natural logarithm of -1. Using a string and ruler, you have seen this before at school, but just take the diameter of a circle, then lie a string around the circle, measure the string, and pi is equal to the length of string over the diameter. Ramanujan's series is a lot more complex and possibly the most terrifying thing I have seen. He was a self-taught mathematician, and I have no idea how this series was found, but it creates very close approximations from only a few terms. For this reason, von Neumann used it and similar formulas for the first computers. Here's if we plug in the first term, which I won't even try to read out, which we can then find the reciprocal of to find 8 digits of exactly pi from only one term. Gauss-Legendre algorithm is similarly confusing and accurate. It includes 4 variables derived from series a, b, t, and p, with the first term of a and p being 1, t being a quarter, and b being 1 over root 2. Each iteration is very complex, and each iteration intertwines each series together. Pi is then approximated using a complex combination of all of them. Pause if you want to read out the exact equation. Now for my favorite, pi is equal to 4. There's a drawing here, which outlines how you can find pi using another circle inscribed in a square. Comment below why you think it doesn't work, and the real answers are in the description.